And here we go, guys. Number 17, the final question of the paper. Whew. So well done, guys, for coming this far. But without further ado, let's go. So we have a circle C with center of -2 and 6, which passes through the point 10, 11. So just a quick recap, the center is always given in this notation A and B, where A is -2 and B would be 6. So I just did a little demonstration here. This middle point here, the center would be A, B, or -2, 6. Now show that the circle C, so the same circle, also passes through the point with 10 and 1. Now this is straightforward. To prove this statement, the whole idea is to show that they have the same radius. Because if this point was on the circle, and this point was on the circle, and this is the center, it must mean that the distance between them must be the same. So I just called it R for the radius. Okay, so that's just a little demonstration. So all you have to do is firstly write down your circle equation, which is of course x minus a all squared plus y minus b all squared equals radius squared, with a and b being -2, so -2 is +2, and minus b would be -6 equals r squared. And now you just test it. You said, okay, so if we plug in firstly the point 10, 11, what happens? So when x is 10 and y is 11, you just deduce the equation and you get 169, which must equal r squared. So therefore, square rooting this will give us a radius of 13. And now we do the same with the point 10, 1. So we say, okay then, so at 10, 1, we replace x with 10 and y with 1, just like you did above. And again, you get 169. It's kind of obvious here because you can see that the difference in the y is just 5 for both. So of course you get the same result. And that's it, you proved it. So therefore they have the same radius, so proved. That's all. Now here comes the final main meat of the paper, yeah? So the tangent to the circle C at the point 10, 11, so over here, meets the y-axis at the point P. I'll show you how I did this. And the tangent to the circle C at the point 10, 1 meets the y-axis at the point Q. So you've got two different tangents. Now, this is the main part. Show that the distance from P to Q, so when they meet the y-axis, is 58. We have to explain every step. Okay guys, so let me show you what I did exactly. Okay, so here we go. So here's everything. So I put the center over here, -2, 6, and of course I put 10, 11, and 10, 1 over here. Now, the reason why the y-axis is between these two is because firstly, the x-coordinate for the center is negative, so it's on the left side of the y-axis, whereas the 2 points are positive, so it's on the right side. Also, if you note carefully, when I drew this line, the radius, here is your tangent, because one thing we need to know about tangents on a circle is that it's perpendicular to the radius, both of them. Makes sense, because it has to touch one point, it's always perpendicular to the radius. And that's fine. And so the key idea is to firstly work out the equation of this line here from the center to this point where 10, 11 is, and find the equation of the line from the center to 10, 1. So let's work at that step by step and you'll see what's happening. And then we can finally work out the distance from P to Q, which is completely vertical, by the way, so that's good. It'll just be a subtraction of the y coordinates. Now, let's start with the line from -2, 6 to 10, 11. So using your general y equals mx plus c, so here's the line, where m is the gradient, the change of y with change in x. We just find the difference in coordinates from -2, 6 and 10, 11. So 11 take away 6, or 6 takes away 11, over the change in x between -2 and 10. That should give us 5 over 12, easy. To find the value of c, the intercept, so where it hits the y-axis, which is this coordinate right here, it just rearranges this equation and makes c the subject. So I did y minus mx, and we have the value m now. Y and x could be any of these 2 points. I'm just working at the center. You could work with that with 10, 11, it should be fine. So plug in all the values, y for 6, x for -2, and the value of m, and you should get 41 over 6, and therefore this point here would be the y-intercept. So you can actually say that this coordinate here is 0 and 41 over 6. So I'll put it over here actually. You can see this coordinate right here. I just called it A as well. Now for the second step, for the second equation, do the same thing here. So from -2, 6 to 10, 1, follow the steps carefully. Find the equation of the line where the gradient is this, -5 over 12, the difference in the points, and find the value of c using the same method, where y minus mx. And again, you get 31 over 6 this time. So this would be this coordinate here. So this upper coordinate here is 41 over 6. This lower one is 31 over 6. And of course, the x coordinates are 0. Now, why do we need this? That is probably what you're wondering. So I've called this one D and this one W. The key idea is to find the value of AP. So this is basically Pythagoras Theorem. You know, we could just call this length AP, which is well done. So the key idea is to find an expression for D squared plus W squared equals AP squared, which I put over here. So for D squared, you could firstly just work out use the distance formula to find the difference between these 2 points, which I did over here. So between 10 and 0, 10 minus 0 squared plus 11 minus 41 over 6 squared. And then for W, you find the distance between 10 and 11 and when the tangent hits the y-axis. I just called it 0p because when something hits the y-axis, the x-coordinate is 0. And it's p because I need to just give it a name. So when you do that, find the difference between them, you should get something like this. W squared equals the following. And for AP squared, do the same thing. Find the distance between the coordinate of A, which is 0, 41 over 6, and P, which is 0 and little p. So same story. Now this is where you get your answer for P. And this is actually one of the correct answers too. To do this, just use Pythagoras theorem. So AP squared equals D squared plus W squared. Substitute the value for AP squared. So I already calculate AP squared. Well, I didn't really. I just put it over here because this term is 0. And for D squared, I literally put this all in the calculator and got 4,225 over 36. Put it there. And for W squared, well, I did the same thing. The first term is 100, and I haven't expanded the second bracket yet. Now all you do is just open the brackets, open this quadratic to get the left hand side, which is over here. Open the quadratic on the right hand side and collect like terms to get something like this. Cancel the p squares across, so let me actually just show that. So these ones go. And then you just solve for p. You know, you can just plus 22p across, subtract this constant term to the right, divide, and then just isolate the p and you should get 35. So I would do this step by step, but this will take a while and it's best to just see the deductions so you guys can try out as well. And now that's what it is. So basically 0p basically becomes 0 and 35. So that's what we wanted. Now for the second equation, it's the same thing. So just looking back at the general graph, we worked out this coordinate. So we know that p here is 0 and 35. Okay. Now we need to find the coordinates of q. So we're going to work with the bottom half, so the tangent from 10, 1 to 0q. Okay, so just repeat the procedure. So again, I call this length here m between q and 10, 1, and I call this length n between b and 10, 1. So this is the tangent points. No, so this is the part where the circle is, yep. The q part is the tangent point. So using the distance formula, so I said let m squared plus n squared equal bq squared. So somewhere over here, yep, bq squared equals n squared plus m squared. Find an expression for n squared, so using the distance formula for every single line. So m would be, for example, m squared equals the distance between 10, 1 and 0q, which looks like this. Subtract the x coordinate squared plus subtract the y coordinate squared, and do for each one. Eventually substitute all of these in like I did for the top one. Replace bq squared with whatever you got here, m squared with whatever you got there, and n squared with whatever you got on the first line. And then solve this for q, and voila, you get minus 23. And then you realize, okay, if this is 0 and minus 23, and because this is a vertical line, remember y-axis is a vertical line, you could just subtract the y coordinates. So 35 minus 23 will give us 58. Done. And that's it, guys. That's literally all I can say for this question. I hope this explanation was clear. I know, you know, of course, solving it step by step would be nice, but I thought I'd try it this way because it did take quite a while to do, and there's a lot of steps. So yeah, anyway, thanks for watching, guys, and if you enjoyed this video, give me a like, subscribe, share to your friends, and I shall see you guys in the next papers. So have a good day and ciao.